The solar system formed over 4.5 billion years ago from a collapsing cloud of gas and dust. At its center is a sun, a massive yellow star surrounded by 8 planets, each with its own unique characteristics. From scorched rocky roads to gas and ice giants, this planet reveals a diversity and complexity of our cosmic neighborhood. In this quick tour, we will explore what makes each one distinct as we journey outward from the sun. Quick moment before we begin. Hit like, subscribe, and let's explore the universe together. Mercury, the closest planet to the sun, is a world of extremes. It's the smallest of the 8 planets, barely larger than our moon, and about a third of the size of Earth. Due to Mercury's proximity to the sun, it races around the sun faster than any other planet, completing an orbit in just 88 Earth days. But despite its speed, Mercury is a slow rotator. A single day on Mercury, from one sunrise to the next, lasts the equivalent of 176 Earth days. Its surface is harsh and desolate, covered in craters from ancient impacts. There are no clouds, no weather, and virtually no atmosphere to speak of, only a tenuous exosphere made of atoms blasted off its surface by solar radiation. Without a thick atmosphere to trap heat, Mercury experiences some of the most dramatic temperature swings in the solar system. Daytime temperatures can soar to over 430 Celsius, while nighttime plunges to a freezing minus 180 Celsius. Yet, for all its apparent simplicity, Mercury holds surprising mysteries. Despite its proximity to the sun, evidence suggests that water ice exists in permanently shadowed craters at its poles, hidden from sunlight for billions of years. And beneath its rocky crust lies a massive iron core, making up about 85% of the planet's radius. This unusual structure gives Mercury a magnetic field, one of only a few solid planets to have one. Mercury is a planet of paradoxes, scorching hot yet hiding ice, small yet dense, silent yet magnetic. It's a reminder that even the smallest planets can hold immense intrigue. Venus. Venus is often called Earth's twin, roughly the same size, made of the same stuff, and located not far away in the solar system. But that's where the similarities end. Venus is a world of extremes, cloaked in mystery and wrapped in a thick atmosphere that makes it the hottest planet in the solar system. Its dense atmosphere is made mostly of carbon dioxide, with clouds of sulfuric acid that reflect sunlight and hide the surface from view. Beneath that toxic haze, surface temperatures soar to over 400 degrees Celsius, hot enough to melt lead. The pressure on Venus's surface is over 90 times that of Earth, equivalent to being a kilometer underwater. Surprisingly, Venus rotates in the opposite direction to most planets, and incredibly slowly. Its day is longer than its year. This bizarre rotation means the sun rises in the west and sets in the east, but you'd never see it from the ground. The thick clouds keep the surface in a state of eternal, orange-tinted twilight. Despite its hellish conditions, Venus has long fascinated astronomers. Soviet landers in the 70s and 80s managed to survive for up to an hour on the surface, sending back eerie, distorted images of a desolate, rock-strewn world. More recently, interest in Venus has surged as scientists explore whether it once had oceans and what turned it into the inferno we see today. Venus is a warning and a wonder, a planet that shows us how similar beginnings can lead to a very different destinies. Earth. Earth is a third planet from the Sun and the only known world to support life. With a diameter of about 12,756 kilometers, it's the largest of the rocky planets. Earth's ability to sustain life comes from a unique combination of factors: a breathable atmosphere, abundant liquid water, active geology, and an ideal distance from the Sun. Located in the Goldilocks zone, Earth is just far enough from the Sun for water to remain liquid, an essential ingredient for life. But location alone is not enough. Earth also has an atmosphere rich in nitrogen, oxygen, and trace gases like carbon dioxide and water vapor. These greenhouse gases trap heat, keeping the planet's average surface temperature around 15 Celsius. Without them, Earth would be a frozen world averaging minus 18 Celsius. Covering 71% of the surface, Earth's oceans regulate temperature, dry weather patterns, and support an immense range of life. Water also enables the chemical reactions necessary for biology. The oceans absorb carbon dioxide and are central to the global water cycle. Around 2.4 billion years ago, Earth underwent the Great Oxidation Event, when photosynthetic microbes called cyanobacteria began releasing oxygen into the atmosphere. This transformed Earth's environment, leading to the formation of the ozone layer and enabling the evolution of complex, oxygen-breathing life. Earth is also protected by a strong magnetosphere generated by its spinning, molten iron core. This magnetic shield deflects harmless solar wind and cosmic radiation, preventing the atmosphere from being stripped away, as likely happened to Mars. Finally, plate tectonics constantly reshape the planet's surface. These slow-moving plates drive the formation of mountains and volcanoes, trigger earthquakes, and recycle Earth's crust. Tectonics also help regulate the carbon cycle, balancing carbon dioxide levels over millions of years and maintaining a stable climate. Together, Earth's atmosphere, oceans, magnetic field, and geology form a finely balanced system, a rare planetary harmony that has allowed life to not only begin but to endure and evolve. Mars. Mars, the fourth planet from the Sun, is often called the Red Planet because of its iron-rich soil that gives it a distinct reddish hue. Though cold and barren today, Mars is the most Earth-like planet in our solar system, with many features that continue to fascinate scientists and space explorers. Mars is much smaller than Earth, about half its diameter, with 15% of Earth's volume and 11% of its mass. Its gravity is just about 38% of Earth, making it easier to lift dust into the thin atmosphere. Classified as a desert planet, its dry, rocky surface resembles Earth's most arid landscapes. The Martian atmosphere is 1% as dense as Earth and made mostly of carbon dioxide with small amounts of argon, nitrogen, and traces of water vapor. Temperatures range from minus 140 Celsius to 20 Celsius, and without a strong magnetic field, Mars is exposed to high levels of radiation. Fine dust fills the air and drives massive dust storms, the largest in the solar system, which can cover the entire planet. Despite the dryness, Mars has water, mostly as ice in its polar caps, permafrost, and thin clouds in the atmosphere. Its ice caps, made of water and frozen carbon dioxide, expand and contract with the seasons. Mars shares a similar axial tilt, 25° with Earth, giving it seasons, though they last much longer due to its 687-day year. A Martian day, or sol, is just 37 minutes longer than an Earth day. Mars once had a thicker atmosphere and liquid water, but as its core cooled, it lost most of its magnetic field, allowing solar winds to strip away a big portion of the atmosphere. The planet slowly dried and cooled, transforming from a potentially habitable world to the frozen desert we see today. Still, evidence of ancient rivers, lakes, and organic molecules suggests that life may once have existed and might even survive underground today. Mars also hosts the solar system's tallest volcano, Olympus Mons, 22 km high, and its longest canyon system, Valles Marineris, 4,000 km long. Mars has two small, irregularly shaped moons, Phobos and Deimos. Phobos, the larger of the two, orbits very close to Mars and is slowly spiraling inward. Scientists believe that about in the next 50 million years, Phobos could either crash into the planet or break apart to form a temporary ring system around Mars. With numerous active orbiters and rovers exploring its surface, Mars remains a key focus in the search for past life and the future of human exploration. Jupiter. Jupiter is the fifth planet from the Sun and by far the largest in the solar system, with a diameter approximately 11 times that of Earth and a mass 318 times greater. It holds more than twice the combined mass of all the other planets. Despite its immense size, Jupiter rotates rapidly, completing one rotation in just under 10 hours. This fast spin causes the planet to bulge at the equator, making it noticeably flattened at the poles. As a gas giant, Jupiter is composed mainly of hydrogen and helium. Its atmosphere, extending about 3,000 kilometers beneath the cloud tops, contains trace amounts of water vapor, methane, ammonia, and hydrogen sulfide. The pressure increases with depth, transforming the gaseous hydrogen into liquid and eventually into metallic hydrogen, a theorized state where hydrogen conducts electricity like a metal. Jupiter lacks a solid surface. Instead, scientists believe it has a dense core of rock and ice, possibly 10 to 50 times the mass of Earth, surrounded by a vast layer of liquid metallic hydrogen. One of Jupiter's most striking atmospheric features is the Great Red Spot, a vast anticyclonic storm that has persisted for centuries. Rotating counterclockwise with a period of about 6 Earth days, the storm is large enough to engulf Earth and towers high above the surrounding clouds. Though it has been gradually shrinking in recent years, it remains a defining feature of the planet. Jupiter also possesses the most powerful magnetic field in the solar system, about 14 times stronger than Earth at the cloud tops, generated by motions within the metallic hydrogen layer. This field creates an enormous magnetosphere that extends millions of kilometers into space. Near the poles, it produces intense auroras far more energetic than those on Earth. These auroras are not only driven by solar wind but also interactions with Jupiter's four largest moons, Io, Europa, Ganymede, and Callisto. These Galilean moons, discovered by Galileo in 1610, contribute charged particles to the magnetosphere as their thin atmospheres interact with the planet's magnetic field. Each of these moons is a world of its own. Io is the most volcanically active body in the solar system. Europa likely harbors a subsurface ocean beneath its icy crust, making it a prime candidate in the search for extraterrestrial life. Ganymede, the largest moon in the solar system, may also have an underground ocean and even possesses its own magnetic field. Callisto, though heavily cratered and geologically inactive, may similarly conceal a buried ocean. The potential for life in these hidden oceans makes Jupiter's moons some of the most intriguing targets for future exploration. Jupiter also has faint rings, not as many as Saturn, but they are definitely there. These rings are mostly made of fine dust, likely ejected from its moons Metis and Andrasta after collisions with asteroids or comets. Saturn. Saturn is the sixth planet from the Sun and the second largest in the solar system, surpassed only by Jupiter. Like Jupiter, Saturn is a gas giant composed primarily of hydrogen and helium. It has a pale yellow hue caused by ammonia crystals in its upper atmosphere. With an average radius about 9 times that of Earth, Saturn is truly enormous in scale. Saturn is perhaps best known for its stunning and extensive ring system, the most prominent in the solar system. These rings are made mostly of ice particles, ranging in size from 1 centimeter to 5 meters, along with smaller amounts of rocky debris and dust. The rings are vast and bright, forming a magnificent halo that makes Saturn one of the most visually striking planets. Orbiting Saturn are at least 274 moons, with 63 officially named. Among them is Titan, the largest moon of Saturn and the second largest in the solar system. Titan is even larger than the planet Mercury, though it's less massive. It is unique for having a thick, nitrogen-rich atmosphere, something no other moon in the solar system possesses. Due to its rapid rotation, Saturn is shaped like an oblate spheroid. It's noticeably flattened at the poles and bulges at the equator. Its equatorial radius is over 10% larger than its polar radius. Interestingly, Saturn is the only planet in the solar system that is less dense than water, about 30% less, meaning it would float if placed in a sufficiently large body of water. Structurally, Saturn is similar to Jupiter. It has a rocky core surrounded by layers of metallic hydrogen, liquid hydrogen, and an outer envelope of hydrogen and helium gas. However, because Saturn is farther from the Sun, it receives less energy and is colder than Jupiter. This results in a generally calmer atmosphere with fewer storms and less dramatic weather patterns. Despite its relative calm, Saturn is home to one of the solar system's most mysterious features, a persistent hexagon-shaped storm system at its north pole. Each side of this hexagon spans about 14,500 kilometers, long enough to fit Earth more than twice across. The exact cause of this geometric weather pattern remains unexplained. In every way, Saturn stands as a planet of elegance, mystery, and sheer scale, an enduring marvel of our solar system. Uranus. Uranus is the seventh planet from the Sun and one of the most unusual worlds in the solar system. It shares some characteristics with Jupiter and Saturn, such as being a giant planet with a thick atmosphere, but it is smaller, more distant, and much colder than both. In fact, Uranus holds a record for the lowest recorded temperature of any planet in the solar system, plummeting to a frigid -224 Celsius. Unlike the swirling clouds and storms of Jupiter and Saturn, Uranus appears eerily calm. Its upper atmosphere is nearly featureless, giving it a uniform blue-green color. This distinctive hue comes from a high-altitude layer of methane ice clouds, which absorb red light and reflect blue and green wavelengths. While Jupiter and Saturn are dominated by hydrogen and helium, Uranus is made mostly of water, ammonia, and methane in a supercritical, slushy state of matter that astronomers refer to as ices or volatiles. Because of this composition, Uranus and Neptune are often called ice giants rather than gas giants. Beneath its icy mantle lies a rocky core, and above it floats a dense atmosphere of hydrogen and helium. Uranus experiences enormous storms from time to time and exhibits strange and still poorly understood atmospheric phenomena. Despite its outward calm, its upper atmosphere can generate winds of up to 900 km/h, and researchers have observed irregular cloud patterns and changes in its polar regions. What puzzles scientists even more is the planet's very low internal heat, far weaker than that of the other giant planets, a mystery that remains unsolved. One of Uranus's most defining features is its extreme axial tilt. The planet is tipped over by about 82 degrees, essentially rotating on its side. It spins retrograde like Venus, with a rotation period of about 17 hours and 14 minutes. Because of this tilt, each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness over the course of its 84 Earth-year orbit around the Sun. Uranus also possesses a strange and highly asymmetric magnetic field. It is both strong, about 50 times more powerful than Earth, and misaligned, offset from the planet's center and tilted dramatically relative to its rotation axis. The exact origin of this chaotic magnetic geometry remains another mystery. The planet has a faint but complex system of rings made of dark particles, ranging from microscopic grains to chunks a fraction of a meter wide. These rings are much less visible than Saturn's, but they offer another glimpse into Uranus's odd character. In addition, Uranus is orbited by over 2,000 known moons. These moons vary in size and composition, and some may even harbor subsurface oceans beneath icy crusts, making them intriguing targets for future exploration. All in all, Uranus is a world of extremes, icy, tilted, and deeply mysterious. It challenges our understanding of how planets form and evolve, and stands out as one of the strangest planets in the solar system. Neptune. Neptune is the eighth and farthest known planet in our solar system. Like Uranus, it is classified as an ice giant with an atmosphere primarily composed of hydrogen and helium, along with higher concentrations of water, ammonia, and methane ices. Although it's slightly smaller than Uranus, Neptune is more massive and denser, making it the third most massive and densest of the giant planets. It has no solid surface, as it is composed mostly of gases and fluids. Neptune orbits the Sun approximately every 170 Earth years at an average distance of 30.1 astronomical units. 1 astronomical unit, or AU, is the average distance between the Earth and the Sun. Despite its distance and cold temperatures, Neptune is surprisingly active. Its deep blue color comes from methane in the atmosphere, which also hosts fast-moving weather bands and powerful storms, including the famous Great Dark Spot, roughly the size of Earth. Neptune is significantly more dynamic than Uranus, with wind speeds reaching up to 2,100 km/h, the fastest in the solar system. Neptune was visited only once, by Voyager 2 in 1989, which revealed much of what we know today. Since then, detailed observations have come from the Hubble Space Telescope and modern ground-based observations using adaptive optics. The planet has 16 known moons, the largest of which is Triton. Triton is unique. It orbits Neptune in a retrograde direction, opposite to the planet's rotation, suggesting it was likely a captured object from the Kuiper belt. It makes up more than 99.5% of the total mass in orbit around Neptune, and is the only Neptunian moon large enough to be spherical. Neptune remains a world of intense weather, icy mysteries, and one of the most intriguing destinations in the outer solar system. Pluto. Pluto was once considered the ninth planet in the solar system, orbiting the Sun just beyond Neptune. Today, it is classified as a dwarf planet and is one of the largest known members of the Kuiper belt, a vast ring of icy bodies that lies beyond Neptune's orbit. Pluto is the ninth largest and 10th most massive object known to orbit the Sun directly. By volume, it is the largest trans-Neptunian object, though it is slightly less massive than Eris, another distant dwarf planet. Like other Kuiper belt objects, Pluto is composed mainly of rock and ice. It is much smaller than the inner planets, about 1/6 the mass of Earth's moon and 1/3 of its volume, yet it remains a fascinating and complex world. Thank you so much for watching this journey through our solar system's planets. If you enjoyed the video, please subscribe and leave a like. It really helps the channel grow. Until next time, keep looking up.